Thank you for this opportunity to talk to you about the Ewaso Restoration Project. It's being implemented in a partnership between my NGO Quench and the Ewaso North River Basin Development Authority. Before I talk to you about technical terms like land degradation and restoration, I'd like to talk about something near and dear to all of us, and that is our cars. If you are like me, you're tempted to bypass that 10,000 kilometer or once a year maintenance requirement, and as a result, our cars may break down. If you're like me, you're tempted to not haul it off to a mechanic, but just wait and let it rest and see if it gets better all by itself. But we know that it won't, because a car is a mechanical organism. It has no capacity for self-healing. Unlike a biological or an ecological organism, such as a plant, an animal, a person, an ecosystem, or a landscape, once drivers of degradation are removed, we have a remarkable ability to heal ourselves. But the prescription needs to be fitting to the ailment, and in some cases it's not. Putting surface water areas in the middle of a desert where the evaporation rates are really, really high is not necessarily a good idea. Water in a desert is money, and allowing your water to evaporate into thin air is like taking a bunch of money and setting it on fire. Similarly, eucalyptus in Kenya is a bad idea. Eucalyptus not only transpires a lot of water, but it also secretes poisons into the subsoil, which means that native vegetation can't reestablish itself, so there's zero chance of restoration of a native ecosystem if you plant eucalyptus. Eucalyptus, my friends, is Chakula cha koala. It doesn't belong in Kenya. A third example is the Great Green Wall that's being planted across the Sahel. Millions of trees are being planted with the objective of sequestering carbon and arresting the southward march of the desert. But these trees not only evapotranspire a lot of water, they also darken the color of the landscape. And scientists have recently found that because dark colors absorb heat, they're actually raising the temperature of the planet. Wishing that your desert was a forest or wishing that it had a huge river running through it is like wishing your car was an airplane and therefore you drive it off a cliff to see if it will fly. It's not a good idea. To put this in context, let's take a look at where the basin is situated. It arises in the water-rich Laikipia Plains and descends through the ASAL arid or semi-arid landscape of northeastern Kenya until it crosses the border with Somalia to join the Juba River as a tributary. The basin is full of valuable natural resources. They're important to the country of Kenya for ecological, economic, and cultural reasons, and they deserve to be protected and restored. But there are a number of drivers of degradation in the landscape, and these are largely related to human activities and largely related to climate change. The basin is now entering its 5th consecutive drought year. Evaporation rates in the lower basin are twice as high as precipitation rates. The lack of water leads to a lack of productive capacity of the landscape, which means it can't produce food. As of September of this year, most of the basin was in integrated phase classification level 3. This is the FAO classification system, level 3 being crisis, level 4 being an emergency, and level 5 being a disaster or a famine. 30% of communal grazing lands have lost grass cover due to overgrazing. This is a reflection of fragmentation of the landscape, not only by urbanization, but also by fencing of the landscape for private uses such as ranches, cattle feedlots, and irrigated agriculture. This fencing excludes wildlife and pastoral animals from a large portion of the historic grazing areas and forces them into smaller and smaller areas, particularly around watering points, where they overgraze the grasses so that they have no capacity to reestablish themselves, and they compact the soils, which makes it impossible for new root systems to penetrate into the ground. Last but not least, water withdrawals from the river and tributaries are increasing steadily over time. This bar graph shows old data, but it's irrelevant because it shows only permitted abstractions, and it's estimated that 95% of the water abstractions from the river and tributaries are illegal and therefore unmonitored and unreported. The objective of our project is to restore pasture wetlands and floodplains with a particular emphasis on pastoral livestock and wildlife, migratory wildlife, as our indicators of ecosystem health. And this is because these animals are compatible with that landscape. They've evolved with the landscape, and they use it in a way that distributes pressure, both over the tiers of the ecosystem and over the geography of the landscape. The components of our project include grassland restoration, negotiated agreements over water use, which will be based on a hydrologic model, which in turn will be based on data collected from River Gauge Station maintained by ENDA and CETRAD since the 1960s. Capacity building of catchment management organizations. These organizations have a dual function. First is to ensure the proper working of the subcatchments in the basin for soil and water conservation, and the second is enforcement of water laws. Pro-nature livelihood support. This will focus on pastoral communities to enable them to have alternative livelihood support so that they're not tempted to always increase their herds to make up for the livestock that are dying of starvation and drought in the desert. To start grassland and pasture restoration, the first step is site selection, and this will be based not only on natural characteristics, but also on the human communities that occupy the landscapes. For natural characteristics, we'll be looking at things such as historic migratory routes for wildlife and pastoral communities, as well as the soils. Are they suited for supported grasses, the moisture regimes, precipitation regimes, topography, and those sorts of things. With regard to human communities, we'll be looking at communities that are willing and able to protect the restored areas from grazing animals until the grasses are established, because otherwise the grass will be destroyed before it takes root, and the restoration effort will be in vain. A contrasting criteria for the human communities is that they should be exhibiting some sign of conflict, because part of the objective of our project is to reduce conflict over resources. Once the areas for restoration have been selected, the first step in many cases will be to remove exotic invasive vegetation. And in this regard, hats off to the Ministry of Environment and Forestry for its battle against Prosopis juliflora, which is known as methenge in Kenya. Ironically, it's native to the Sonoran Desert, where I got my degree in wildlife biology. It's called mesquite there, and it forms natural woodlands or bosques along rivers and streams that are wonderful habitat for doves and quail. And in fact, in the hunting season, you can find lots of signs of wildlife in these woodlands, such as discarded beer cans and ATV tracks. It's also really good for barbecuing, but it doesn't belong in Kenya. The second genus that we're concerned about is a Puntia species, which is known in the Americas as prickly pear cactus. It's native to the Americas from Canada south to South America. Like the Euphorbiaceae that's native to Africa, it's a succulent, which means that it's adapted to desert environments. It stores water in its biomass, which makes it very seductive for thirsty wildlife in the desert, and it has to protect itself with thorns. In fact, we had a graduate student who would enlist undergraduate volunteers for his study on ringtails, which eat the fruit of a prickly pear. And Chevy, our graduate student, just delighted in taking embarrassing photos of his undergraduates with the ringtails, both of us completely full of thorns. Doesn't belong in Kenya. Then the third species that we're concerned about is Acacia repiens. Acacia trees are native to ASAL areas in Kenya, but this one is native to South Africa. And like all invasive alien vegetation, It's opportunistic, which means once the native vegetation is removed, it has an opportunity to spread itself, and it's very difficult to get rid of. It needs to be eradicated either through mechanical means, such as bulldozing, or through burning, which I can attest is a lot of fun for undergraduates. The second component is negotiated agreement over water use. This will be based on the water cycle. I think we all learned about the water cycle when we were in primary school. Water, as it passes in clouds over the slope of a mountain area like Mount Kenya, condenses and is forced to fall as precipitation on the surface, which may be a water area. Rarely, there's no ocean in the Ewaso Basin, although with climate change and sea level rise, who knows, one day there may be. A lot of it is transported through the shallow surface soils towards the receiving surface water areas like tributaries, in which case it's transported downstream. But along the way, it moisturizes the soil and it supports vegetation like trees, grasses, and crops. Some of it will infiltrate through cracks in subsoil areas, in bedrock and sand lenses, until it reaches outflow. And it can't be charted by the topography of the landscape. It has to be charted using observational boreholes that show the underground subsurface layers of the landscape and where that water is actually going. These compartments of the water cycle are represented in an object-based hydrologic model by geometric shapes. The shapes contain hydrographs, which are those squiggly lines showing high flows and low flows over time within each compartment, and they're linked together by arrows that show the relationships between the compartments, so that a water user in Laikipia, for example, can understand what his or her withdrawals are doing during certain times of the year in terms of the total flows and the water users lower in the basin. That Laikipia water user may agree to release more water in August in exchange for diverting more water in March. So there's a basis for agreement once you understand on an objective basis how the system functions as a whole. The third component of our project is capacity building of catchment management organizations. These organizations have a dual function, as I mentioned. One of them is to ensure the proper functioning of their subcatchments. And this is done by training them in the understanding of the mechanics of that subcatchment. What are the soils? What is the precipitation regime? What are the native channel structures of that subbasin, so that they can decide where to place soil and water conservation structures, such as tree hedgerows and grass strips, that will actually capture soil particles as they're washed downstream during a rain event and build up those soils on the landscape to make the landscape more productive. And at the same time, they're trapping water, slowing water down so that it has a chance to infiltrate into the surface soils and deeper into the aquifers, such as the Verde aquifer, and it's released more gradually into the channels so that there's more water available for producing vegetation on the landscape, and there's also a steady base flow in the surface water systems, and that means the channels of the river will no longer go dry. The second function that they have is identifying illegal abstractions of water. And they can help to bring the illegal perpetrators of these abstractions to justice and make them a productive and cooperative part of a basin-wide effort to restore the proper functioning of the Ewaso Basin ecosystem. The fourth component of our project is pro-nature livelihood support focused on pastoral communities. These are activities that pastoral communities can already engage in and are already engaged in as they move from place to place along the landscape. Gums and resins, for example, have industrial applications such as in adhesives and solvents, and also in incense, frankincense and myrrh, the three wise men since it's Christmas season, and lotions and those sorts of things. They need processing facilities. They need development of value chains. The ENDA has already constructed a gums and resins processing facility. It just needs a few more tweaks and turns to make it fully operational, and it needs receiving marketing chains on the other end to make sure that products are developed and distributed and sold and making money in other parts of the region and other parts of the world. A second value chain is camel milk. Camels produce more milk over a longer period of their lifespan than cattle do. They can also be pastured further away from water sources, 8 kilometers as opposed to 1 kilometer for a cow. Therefore, they are well adapted to the ASAL environment, and their products are becoming more popular, but again, they need construction of value chains and marketing. The third one is inclusion of more browsers amongst the pastoral herds so that the animals are eating more woody vegetation as well as grasses, which contributes to an alleviation of the overgrazing issue and allows grasslands to continue to restore themselves. In summary, our project addresses all of the drivers of degradation in the basin. It addresses drought by increasing soil moisture in the catchment, by restoring pasture and grassland areas and wetlands and floodplains, and by empowering catchment management organizations to increase the productivity of the landscape through installation of soil and water conservation measures. And it addresses drought by increasing flows from the upper basin to the lower basin so that pressure on the landscape is distributed more evenly over these resources. Overgrazing it will address by increasing the area of pasture and also by encouraging mixed livestock herds in pastoral communities that will distribute pressure from grazing on woody vegetation as well as on grasses. Over-abstraction of water will be addressed through a process of negotiated agreement, which will lead to improved coordination of water use. And invasive vegetation, you just have to get rid of it and replace it with native vegetation. So, in conclusion, our process will set in place that virtuous cycle of self-restoration and healing, starting with the restoration of grasslands and wetlands, which will lead to increased landscape productivity because there's more moisture and more productive soils on the landscape, which allows for production of crops and grasses for consumption by livestock. And the communities living in that basin will have better income streams and access to more food. So they'll be less stressed out and less prone to fighting, which will reduce conflict in the basin. And that reduced conflict will create an environment that's conducive to negotiated agreements over sharing of resources, which will distribute the use of those resources more evenly over both the geography of the landscape and over time, which will reduce pressure on pasture and water resources, which will create the opportunity for that virtuous cycle of self-healing and restoration to keep itself going. These are the responsibilities for the project as we see them. Thank you very much for your time and attention.